Guys, and welcome back to the channel. Today we're going to be going through the third part of trigonometry, going through some more exam-y type questions. We went through some harder ones before at the last bit of that video, but now we're going to be going through some specific exam type questions and just applying everything we know. So without further ado, question 1. Okay, showing all the necessary workings, solve the equation cot theta plus cot theta plus 45 degrees equals 2, right? So, what is cot theta? What's 1 over tan? So we say 1 over tan theta, okay, plus 1 over tan theta plus 45 degrees is equal to 2. Okay, now remember that tan theta plus 45 can be expanded, right? It could be expanded to equal, well, if we look at the the technical identity, tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B, right? So, in this instance, what we've got then is 1 over tan theta plus 1 minus tan 45 tan theta, okay, over tan theta plus tan 45. Okay, and that equals 2. Tan 45 just equals 1, right? So we get then 1 over tan theta plus 1 minus tan theta over 1 plus tan theta is equal to 2, right? Therefore, what can we say? Well, we need to times by tan theta 1 plus tan theta. So therefore, we get 1 plus tan theta, okay, plus tan theta 1 minus tan theta over tan theta 1 plus tan theta equals 2, right? And we can then multiply that across. We can say 1 plus tan theta plus tan theta 1 minus tan theta is equal to 2 tan theta plus 2 tan theta squared, tan squared theta, sorry. Right, and if we simplify this entire thing, what we then get is 3 tan squared theta is equal to 1, right? Which means that tan squared theta is equal to 1/3, which means that tan theta is equal to 1 over root 3 plus minus, right? So therefore, tan theta is equal to 1 over root 3 or negative 1 over root 3, right? So let's take a look at this, right? Because this is a important point to consider. If tan theta is equal to 1 over root 3 or negative 1 over root 3, what are we going to say? Okay, and this is a good way to graphically clear things in your head regarding these. Tan is equal to opposite over adjacent, right? So if tan's positive, we're going to be in these quadrants. So if we draw a triangle here, draw a triangle here, Okay. What we then get, okay, is the basic angle being 30 degrees. Okay, and that means, therefore, that if we're going to go all the way around, okay, that means that theta is going to equal 180 plus 30, which is equal to 210. However, that is not within our bounds. Okay, so we can't use that. Okay, so that basically does it for the positive side. Now, what about the negatives? For negative, -1 over root 3. Well, in that scenario, okay, tan is negative in these quadrants. Theta here and theta here. So we got 360 minus theta. Okay, so 360 minus 30 degrees. Well, that's obviously out of the bounds. But over here, we've got 180 minus theta, right? It's going all the way around, and we're getting rid of this. So we look like this. And that's going to equal 150 degrees, and that is within the bounds. Okay, so therefore, for this question, the answer is going to equal 30 degrees or 150 degrees. And this is a good way to use the cast diagram that simplifies it out. It really makes it so much more simple instead of trying to do everything algebraically. Right, guys, now for question 2, okay, it says, show that 2 sine x minus sine 2x over 1 minus cos 2x is equivalent to sine x over 1 plus cos x, right? So what we're going to do here is we're going to attack the left-hand side. Okay, so if we go for the left-hand side here, what we get is, obviously, we start off with 2 sine x minus sine 2x over 1 minus cos 2x. Okay, if we expand this out now, we got 2 sine x minus 2 sine x cos x over 2 sine squared x. Okay, we can take out a common factor of sine x now, so we get 2 sine x 1 minus cos x over 2 sine x 2 sine squared x, sorry. And from there we can say, well, what is 1 minus sine squared x equal to? Well, we get 2 sine x 1 minus cos x over 2 1 minus cos squared x, right? So we then get 2 sine x 1 minus cos x over 2 1 minus cos x 1 plus cos x, right? And then these can cancel, and these can obviously cancel. So therefore, what do we get? Well, we get sine x over 1 plus cos x. Okay, so therefore we can say left hand side is equal to right hand side as required. Right, guys, now for question 3, it says, showing all necessary workings show that sine theta minus 30 degrees plus cos theta is equal to 2 sine theta. Okay, and that's between 0 and 180. So, to do this, right, we need to firstly expand this, right? So the way you do that is we're going to say, well, we know that sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta, and we know that sine alpha minus beta, okay, is equal to sine alpha cos beta minus cos alpha sine beta. Right, so therefore here, what do we get? Well, applying that, we get sine theta cos 30 minus cos theta sine 30 plus cos theta is equal to 2 sine theta. Okay. No, cos 30 and sine 30, what do they give us? We get root 3 over 2 sine theta minus a half cos theta plus cos theta is equal to 2 sine theta. Right? Brilliant. So, where can we go from here? Well, we can take the minus, we can take 2 sine theta on the other side. Right, so what we get then is, that can give us root 3 minus 4 over 2 sine theta, okay, plus a half cos theta equals 0. And therefore, obviously, root 3 minus 4 over 2 sine theta is equal to negative a half cos theta, right? And therefore, sine theta over cos theta is equal to negative a half times 2 root 3 minus 4, which means tan theta is equal to 0.441. Okay. Now, if we apply our arctan here, we get 23.8 degrees. Right. So, just a quick one on this. Obviously, I'll kind of calculate that all together. But 0.441, okay, it's negative 1 over root 3 minus 4, right? So tan's positive. Tan is positive. So tan is positive, therefore, if we go to our cast diagram, tan is positive here and here. Okay, so therefore theta 23.8 here. If we go all the way around here, we say theta is equal to 180 plus 23.8, which means the 180, well, that's obviously our bounds, right? So therefore the only answer here is going to be 23.8. Alright guys, now here we've got cot 2 theta is equal to 2 tan theta, and that's between 0 and 180 degrees, right? So what I'm going to do here is I'm going to say, well, 1 over tan 2 theta is equal to 2 tan theta, right? Which means, using our tan 2 theta formula, which is 2 tan theta over 1 minus tan squared theta, right? That means that we get here 1 minus tan squared theta over 2 tan theta equaling 2 tan theta, right? So then, 1 minus tan squared theta is equal to 4 tan squared theta, right? That means that 5 tan squared theta is equal to 1. Tan squared theta is equal to 5. Okay, so tan theta is equal to plus minus 1 over root 5. Okay. So let's assume now that tan theta is equal to 1 over root 5. Therefore, theta is going to equal 24.1. Okay, so in this instance, tan is positive. Okay, where tan is positive, we are in these quadrants. Okay, so what does that mean? We're going to have 180 plus theta. Is that within our bounds? It isn't. Okay, so for that one, we just get 24.1. I don't know what's going on there. Okay, now when tan is negative, we are in these quadrants, which means what? Well, we've got 180 minus theta here, and obviously theta, and 360 minus theta. But what's our period? 180, right? So we've got 180 minus 24.1, right? And that's going to equal 155.9 degrees. So therefore, these are going to be your final answers, nothing else. All right, guys. Now for question 5i, right? Question 5i, it says express root 6 sine x plus cos x in the form r sine x plus alpha, right? So for this one, we're going to say the following, right? We know that sine theta plus alpha is equal to a sine theta plus b cos theta, r there actually, right, by virtue of our compound angle formula. Okay, our a's and b's are going to be constants. So using that, right, using that, we can say, all right, r is going to equal root 6 squared plus 1 squared, which equals root 7. Okay, now tan alpha is equal to what? Offset over adjacent. Okay, and therefore that's going to equal 1 over root 6, which equals 22.08 degrees. Okay, so therefore root 6 sine x plus cos x is going to give me root 7 sine x plus 22.28 degrees. Okay, and that's going to be the answer for number I. Alright guys, now for number II, it wants us to solve the equation, okay, accordingly. So it wants us to solve the equation equaling 2 for 0 to 180. Right, so we've expanded, so we know what this is. and we've shortened it to this. But over here, x is equal to 2 theta. That's the only difference. So we can say that root 7, okay, sine 2 theta plus 22.208 is equal to 2. Therefore, sine 2 theta 0.208 is equal to 2 over root 7. Right. And what can we say? Well, 2 theta plus 22.208 is going to equal arc sine to root 7. Okay, we know that. Which means that it's going to equal, okay, it's going to equal 49.107 degrees. So I'm going to say if we let 2 theta plus 22.208 equal k, okay, so our angle is 49.107. This is simply just to simplify things. And what are we working with? Sine. So CAST. Sine is positive in these quadrants. Okay. And so that's going to equal 180 minus theta over there and the reference angle. So therefore K is equal to 49.107, or K is going to equal 130. Okay, 0.893 degrees. Right? And that means that 2 theta plus 22.08 is equal to 49.107, and 2 theta plus 22.208 is equal to 130.893. Okay, which means that 2 theta is going to equal 26.899, or 2 theta is going to equal 108.685, which means that theta is going to equal 13.4 degrees, or theta is going to equal 54.3 degrees. Alright guys, now similar situation for question 6. Okay. It wants us to express in the form aura cos x plus alpha. Right, between 0 to 90 degrees. So, aura. Aura is going to equal root 2 squared plus root 5 squared. Okay, which means that aura is going to equal root 7. Meanwhile, tan alpha, okay, opposite of adjacents, root 5 over root 2, which means that alpha is going to equal 57.688 degrees. Right? So therefore, that's pretty easy, right? So we've just made it, we can say that we get, in this form, it's going to equal root 7 cos of x plus 57 plus 688 degrees. And that's going to be the final answer for A. Alright, now similar to the previous one, it says now, hence solve the equation root 2 cos 2 theta minus root 5 sine 2 theta equals 1. Okay, for theta being between 0 and 180. So then, how do we do that? Well, it's very simple. If you think about it, just x equals 2 theta, right? That's in essence what's happened here. So what we can say is we're going to get root 7 cos of 2 theta plus 57.688, okay, equaling 1, right? Which means that cos 2 theta plus 57.688 is equal to 1 over root 7. Right? Which means what? Which means then that 2 theta plus 57.688 is equal, okay, to the basic angle of 67.792. So I'm going to say let this equal k now, just like I did before. Just like I did before. Okay, and when I do that, what I'm getting as a result, okay, on my diagram is where is cos positive? It's positive on these fronts, right? Right. So that's going to equal 360 minus theta, or just the reference angle. So 360 minus 67.792. So we can say that k is equal to 67.792, or k is equal to 292.208, right? Which means that 2 theta, okay, if we minus 57.688, the 2 theta is equal to 10.104, okay, or 234.52, which means then that theta is equal to 5.1 degrees, or theta is equal to 117.3 degrees. Okay, these are going to be your final answers. All right, and what's our period? Okay, 0 to 180 using cos, so it's 360 degrees, and yeah, it checks out. There's no other solutions here. We're timesing by multiples of 360. So these can be your final answers. All right, guys. Now for number 7, okay, 7a, it wants us to show that tan theta plus 60 degrees equals 2 cot theta can be written in this form. So the way you do that is you say this. Okay, first off, what is tan theta plus 60 degrees? Well, tan theta plus 60 degrees is equal to tan theta plus tan 60 over 1 minus tan theta tan 60. Okay, and that's equal to 2 over tan theta, right? So tan theta plus root 3 over 1 minus root 3 tan theta is therefore equal to 2 over tan theta. Right, so now it's very simple, we just expand it out. So tan theta plus root 3 is equal to 2, 1 minus root 3 tan theta, right? Which means then that tan squared theta plus root 3 tan theta is equal to 2 minus 2 root 3 tan theta, which means that tan squared theta plus 3 root 3 tan theta minus 2 equals 0. Okay, so that's been shown as required there. Alright guys, now for number B, it wants us to do the following. It says, hence solve the equation tan theta plus 60 degrees equals to 2 cot theta for this period. And we've already put it in this form. So all we have to do is basically solve this problem. Okay, so that is tan squared theta plus 3 root 3 tan theta minus 2 is equal to 0. Okay, and we can now use the quadratic formula. So we can say tan theta is equal to negative 3 root 3 plus minus b squared minus 4ac, right, over 2a. So tan theta is therefore going to give me negative 3 root 3 plus root 35 over 2, or tan theta is going to equal negative 3 root 3 minus root 35 over 2. Okay, so therefore tan theta is equal to 0.35996. So theta is equal to 19.8 degrees. Okay, or tan theta is equal to negative 556, which means that theta is equal to, bear with me, let me just calculate it. Okay, it's going to equal negative 79.796. So, in fact, I can just round that up. Negative 79.8, right? So we've got two situations here. Okay, in situation 1, 19.8 positive. Our cast diagram. Okay, tan is positive, so therefore we're in these two quadrants. Okay, so we've got theta here, then we got this angle here, so 180 plus theta. But obviously if we add 19.8, okay, we're outside the bounds, so we can't do that. Okay, so 19.8 for the positive, that's all we got. Now, why have I kept it as negative 79.8? Because others would maybe just keep it positive. Because here's what I'm going to do. And this is very key with cast diagrams. This is how you make things so much easier for yourselves. Is to just draw the triangles. Okay? Don't get too fancy, just draw the triangles. Because if we draw the triangles, and we kind of work out tan for each triangle, then we get the answer. Okay, so this is where tan is negative in these two quadrants, and we're going to pretend that's negative, that we've gotten a negative here, okay, and we're just going to work out tan of 79.8 degrees for each of these triangles. So in this instance, okay, that is 180 minus theta. Okay, so and then in this instance, it's 360 minus theta, which means we get what? Okay, well, 180 minus 79.8, right? 180 minus 79.8, okay, that's 100.2. And 360 minus 79.8, that's obviously not going to be within our bounds. Okay, so therefore, theta is going to equal 19.8 degrees or 100.2 degrees. And those are going to be your final answers.